Set, go.
Hi, I'm Olivia,
I'm Camille.
and we're going to teach you about conservation laws.
Let's start with energy. All stationary moving objects have energy. When energy can be transferred from one object to another, it can be used to do work. There are two main types of energy, potential and kinetic. Potential energy is the kind of energy that comes from an object at rest, and there are two kinds of potential energy. The energy that comes from height is gravitational potential energy, which has the formula U equals mgh. The next kind is spring potential energy, which is the energy that comes from a spring, and the formula is Pe equals 1/2 kx squared. Next, we'll consider kinetic energy. Kinetic energy is the energy that comes from motion, and it has the formula K equals 1/2 mv squared. All these equations for energy have the same unit, which is joules. The total mechanical energy is the total amount of energy in a system. The kinetic energy at its peak is equal to the potential energy at the lowest point, and vice versa. This demonstrates that energy is always conserved in a system.
A rubber ball with mass 0.2 kilograms is dropped vertically from the height of 1.5 meters above the floor. The ball bounces off the floor, and during the bounce, 0.6 joules of energy was lost. What is the max height of the ball after the bounce? From the problem, we know m equals 0.2, g equals negative 9.8, the beginning height is 1.5, and we need to find the second height. To find the max height, you want to find the max potential energy first. That is U equals m times g times h. So U will equal 0.2 times negative 9.8 times 1.5. So U will equal 2.943. Then you want to subtract 0.6 because that is the energy loss. So that will equal 2.343. Then to find h, you will use the equation U equals m times g times h. So you have 2.343 equals 0.2 times negative 9.81 times h. Once you do the math, you'll get h equals 1.2. So that is your max height, 1.2 meters. Now let's go over work. Work is the change from energy from one object to another. The equation for work is force times displacement times cosine of x, or basically the change in energy, which is delta of mechanical energy. With work comes conservative forces and non-conservative force. For conservative forces, the work done by it is independent of its path, so only the initial and final position matter, while non-conservative forces, the path does matter. Some example of a conservative force is gravity and elastic, while some non-conservative forces is applied force, tension, and friction. Now let's go over how to graph work. For work, you put force on the y-axis and distance on the x-axis. The area under this graph is your work. This will even work with varying force. A varying force is when a force is not constant or not staying constant. An example of this is when you push a box, the more you push, the weaker you get, so your force is varying on the box. Now this is different from a constant force because the force for a constant force is constant. Now let's talk about power. For power, work is done per time. So the equation for power is work divided by time, or since work is just the change in energy, power can be delta E over time. The unit for power is watts. Now how do you graph power? Power is the same as work. You take work, put it on the y-axis, and time, and put it on the x-axis. Let's talk about impulse. Impulse is the amount of force exerted on an object multiplied by time. Impulse is force times time. The unit for impulse is joules. To graph impulse, you put force on the y-axis and time on the x. For vector dot product, you times one vector to another one. If you have multiple vectors, you times one to another one, and then you add two other ones multiplied together. For example, if you had A1, you'll times it by B2, plus A2 times B2, plus A3 times B3. This will give you AN times Bn, which is the sum of all the vectors.
Linear momentum is P equals mv. That means the momentum of an object is equal to its mass times velocity. The change of momentum is called impulse. It's also important to remember that momentum comes from motion. So an object at rest has inertia, but not momentum. For an object to have momentum, it must be moving. When dealing with momentum, it is important to remember what type of system you're dealing with. Open systems are open with the environment, and energy and momentum can be gained or lost. Closed systems are restricted to the objects being considered, and momentum is conserved even if there is a collision. There are two types of collisions, elastic and inelastic. Elastic collisions occur when colliding objects retain their properties when they collide. This is demonstrated by these two cars hitting each other. After the collision, they still retain their own shapes and properties. This is also shown when these two bottles collide together.
In an inelastic collision, kinetic energy is not conserved. In a perfect inelastic collision, the objects stick to each other. An example of this is a car crash.
So here's our equation. A .15 kilogram baseball flies rightward at 15 meters per second to hit a tennis ball flying at it from the opposite direction at 22 meters per second. The baseball and the tennis ball have final speeds of 1.2 meters per second and 13 meters per second, respectively, both to the right. So what is the mass of the tennis ball? So let's start by remembering that momentum is conserved. So that means the momentum we start with is the same amount of momentum we end with. That gives us a starting equation: m1 times v1 plus m2 times v2 is equal to m1 v1 final plus m2 v2 final. Our final goal is to solve for m2, or the mass of the tennis ball. So to do that, we have to rearrange the order of the equation so that way the masses are on opposite side. That way we can isolate m2 when the time comes. That leaves us with the final equation: m1 times v1 minus v1 final is equal to m2 times v2 final minus v2. Because we move the masses to opposite sides, we can now solve for m2 by dividing both sides by v2 final minus v2. This gives us the final equation of m1 times v1 minus v1 final over v2 final minus v2. Now it's time to replace the values and solve. m1 is 0.15 kilograms, v1 is 15 meters per second, v1 final is 1.2 meters per second, v2 final is 13 meters per second, and v2 is negative 22 meters per second because it was going the opposite direction in the first place. So once you plug these values in and solve, you get your final answer of 0.06 kilograms for m2, or the mass of the tennis ball.
Go.
That's all you need to know about conservation laws.